Hey, welcome back to part 3 of Hex-Cube map generation using visual scripting in uNode. In this episode, we will be creating bounding walls around our hex map. We'll continue using the uNode C# class component, and then we'll finally finish up the logic for the cube, flat hex, and pointy hex. So we're going to go ahead and start off with the game manager script, and we're going to create a new method or function called create walls. So go ahead and click on the plus button next to the functions and select add. We're going to go ahead and call this new method or function create walls. Once the function is created, we're going to go ahead and update the summary so we have good documentation. It's always important. Once we've updated the summary area, we're going to go ahead and click on the start function and drag and drop in the create walls method, and we will link that to the create grids right underneath the create grids. Once you're done adding the function, go ahead and click on the create walls again, and we'll start adding the logic in here. What we're going to do is basically create a wall on each side of the grid, which will really be just a collider so that maybe our camera can't go outside those walls. We do want to go ahead and create a local variable called walls GO, or walls game object, and make it of type game object. This was missing in the video, unfortunately. Then we're going to go ahead and drag that walls game object and click set, and then what we're going to do is set the new game object to the walls local variable game object. Next thing we're going to do is we're going to set the wall game object dot layer equals the layer mask dot name to layer of a wall collider. So we will have to create a wall collider layer. We'll create that layer here in a second, but first we're going to go ahead and set the layer node. So you're going to right click on the canvas and add node set, and then we're going to search in the box here for layer, and that should be under the game object. That should add the set value node along with the game object.layer node together. And then what we're going to do is plug the local variable walls game object into the game object.layer. That will set up the first portion of the set value, but we also need to complete the second portion of it. So we need to go find the layer mask.name to layer. So right click and select add node, or you can drag from the pin of the set value and search for name to layer. This pin is an integer, but it does allow us to type in a string value of the collider name here. We want this to match the collider we create later on. Next step is we're going to set the value for the wall collider size. We're going to add the component of box collider dot size and define what size that is using a new vector 3. Right click on the canvas and select add node set, and then search for the box collider.size. So we're going to go ahead and get the add component in brackets T, and that's kind of a temporary, or we can define that. And so when you click on it, another menu will pop up, and we'll go ahead and select box collider. So that will be add component, and in brackets box collider.size. And what we're going to do is grab the local variable wall.game object and plug it into that pin. So we need to finish up with the set value with the vector 3 that's still left. So that's going to be a new vector 3, and we need to define the size of that box collider that we want to create. We're going to go ahead and define the size of the box collider based on the grid width and tiles and the tile width. So we'll do a little bit of math here. I'm guessing that I probably won't be 100% correct, but we should be able to at least get some box colliders around our game board. Once we've created our box colliders, we do want to position them. So we're going to set the transform.position of the wall game object that we just created. So go ahead and right click on the canvas, select add node set, and type in transform.position. Then we'll go ahead and grab the game object.transform and we'll plug in the local variable wall geo get to that GameObject.transform. Now we will define a new vector3 on where we want that located, and that will be based off of the grid width and tiles as well. So go ahead and you can drag from the set pin value, select a new vector3 with the 3 float options. So there will be some math involved here to figure out where we want the walls to be located. So again, we're going to drag in the tile width. We're going to grab the grid width in tiles, and we're going to go ahead and do some math. I did mention how to grab the multiply and the divide nodes previously, so I'm not going to talk through that specifically now, but as you can see in the video, we will link up some math nodes to be able to calculate where to properly locate those box gliders that we're instantiating. Next section we're going to add is we're actually going to parent the box gliders that we created underneath the game board itself, so we're not making a big mess in the hierarchy during play. So right click on the canvas, add node set, type in transform.parent, add that should add both the set value and the transform.parent. We drag in the local wall geo game object and we connect it to the transform.parent. It does ask us if we want to convert it, and in this case we do. Finishing off the set value here is going to be a this.component.transform, or in code it's just this.transform. The transform component is an inherited member of the game object this, or the game manager, so we want to make sure that underneath the inherent member section we select the game object. This now creates one wall for us, so what we can do is we can add a region around this. The easiest way to add a region is actually to highlight all of the nodes and then select add region, or you can resize the region as needed. But this is wall 1, and we are going to copy and paste wall 1 for wall 2, 3, and 4. And we're going to change a bit of the math so that they end up in different locations. So go ahead and highlight all of the nodes minus the start, and then paste. What we're going to do is link the very bottom of that set value for the parent to the top value of the new game object. Once we do that, we need to rotate the second and fourth walls 90 degrees so they're offset from the other two walls, so it's a big box basically. So we're going to go ahead and add a transform.rotate. We're going to go ahead and grab the transform.rotate with the vector3 and the relative space, or relative to. Grab the local variable wall geo, set, and we're going to grab the GameObject.transform and plug it into the transform.rotate. You can type 90 in the y-axis to rotate this particular box glider 90 degrees. Then what we're going to do is copy both the first section and the second section. That's the first wall and the second wall, and create the third and fourth wall. Once we've copied and pasted those, we'll go ahead and link them together. Now we have all four walls of the code created. We'll go ahead and put regions around each of these so we can easily identify each of the walls in case we need to come back to it. Right click on the canvas and select add region. Change the color and change the name if so desired. An even quicker way would be to highlight all of the nodes that you want to put the region around. Right click on add region after they're all highlighted, and this should automatically size the region to all of the nodes that you have highlighted. When we originally created the first new game object, I called it wall 1, and what we'll want to do is update those so it's wall 2, 3, and 4 respectively. For wall 2 and 4, we will need to change the position a bit, so we will relink the vector 3 to the x-axis instead of the z-axis. We're also going to define the float differently for this, or at least set it to 0, so we need to select float from the drop down and just leave it as 0. That kind of resets it. So on wall 4 we just updated the name, and then we are relinking that to the x-axis and removing the link to the z-axis, and then also grabbing the float value and then keeping that as 0. For walls 3 and 4, we need to put a negate option. I did forget that, so we need to put a negate option for their position, so they're the opposite of walls 1 and 2. So we can't forget to go ahead and actually create the layer. So click on the layers drop down, click on add layer, and type in a layer for wall colliders. Just make sure it's the same name we typed in for the name to layer node that we did earlier. We need to do a little bit of updating here for the box collider size. We need to add the grid width in tiles multiplied by tile width plus 10 and attach that to the x of the new vector 3. We need to do the same thing for wall 2, so we're going to go ahead and copy them and paste what we just did from wall 1 to wall 2, and we will link it. Also notice I updated the z values to 0.5. We're going to do the same thing for wall 3, and we're going to do the same thing for wall 4. We should just be able to paste. I actually added the wrong rotate here. This one has a angle in it, and we don't actually need the angle value. So I'm going to go ahead and grab the transform.rotate, which is a vector 3 space or relative to, and select that one instead. Once that looks good, we'll go ahead and copy this, and then we'll paste it into down for wall 4 as well. Wall 4 looks incorrect also. Alright, so that wraps up creating the walls, and that should create 4 walls around our environment. We want to go back to the calculate world coordinates and add additional logic for the flat top hex, which we didn't have before. This information that we have here for the hex logic is actually for the pointy top hex. So we're going to add a couple of if statements to see if is pointy hex, and if it is, we're going to do something. If it's not, we're going to shuffle down and do a flat top hex logic. Go ahead and right click on the canvas, select the if statement. We're going to select, or we're going to pass a connect in the if statement to the next if statement, and so we'll grab the finished pin and plug it into the if is pointy statement. We're going to move some of these around so it makes a little bit more sense. Alright, so now that I've moved everything around, we'll go ahead and update the text here so it's pointy hex logic, and then if the is pointy hex is false, we're going to drop that down to a new section for the flat top hex. So we're going to go and set the local x and local z variables to some additional values. So drag and drop those in and click on set, and we'll set those based on initial position and some math, and the grid position and some math. So we'll go ahead and highlight this, make a region, and identify this as the flat top hex logic. Alright, so here we're going to go ahead and get the initial position. we're going to get the vector3.z of the initial position and subtract that. We'll plug that pin into the set value node of the X. We're going to go ahead and get the grid position. Remember, this is the input parameter of the method itself. So right click and select add node and click on type in grid position to find it and bring that onto the canvas. Then we're going to have the vector3.z multiplied by the tile width. And then that'll be multiplied by 0.75. And all of that will be added, connected to the bottom pin of the subtraction node. Now we'll go ahead and set the z value, and that means we'll go ahead and grab and set or get the initial position of the vector3.x, add that to the offset that we created in the local variables section. We're going to add all of this to the grid position vector3x multiplied by the tile height. So we'll go ahead and grab the grid position by right-clicking on the canvas and typing in grid position. We'll then drag from that pin and type in vector3.x, or just x quickly. That'll pull it up a lot quicker. Less typing, of course. Then we're going to multiply that by the tile height. So go ahead and grab a multiply node, drag in the tile height, get that, connect that to the multiply pin, and then add those two sections together. The results of that will be plugged into the z value, the set z value. Like we did before, we need to return that value because the calculate world coordinates does do a return type of vector3. So right click on the canvas, type in return, and bring that into the canvas. And then we can copy and paste from the one above and plug that into the return node. And then connect the return node into the main flow of the graph. Looks like it inadvertently added a addition instead of a multiply here on this one, so we're going to go ahead and swap that out. We'll go ahead and change that to 0.75 and connect the multiply to the multiply, and then the multiply to the subtraction, and go ahead and get rid of the addition node. We do need to bring in an if statement, and we can copy that from above. But similar to the pointy hex area, we need a similar if statement. So we're going to go ahead and grab this, and we're going to go ahead and paste it down below. We'll use this, and we'll go ahead and get an if statement. The only reason I didn't grab that if statement is because I didn't want all the links with it, so it was just easier to type it in this way. We are going to plug the finished pin into the main flow of our flat top hex logic, and then we will link the if statement from above, if it's false, to this particular if statement. We're going to go ahead and make a little bit of room here so it all fits into our region correctly. Now, if this if statement is true, we need to set the offset tile height divided by 2. So we'll go ahead and grab the tile height get, divide that by 2, and set the offset. So go ahead and grab the offset from the local variables and set it. Due to the way I arrange the if statements at the top of the pointy hex logic, I need to move this is pointy hex kind of out of the region and reconnect things. So let's do that now. There we go. We'll move this up out of the region itself, and then relink these correctly. Alright, now that we've rearranged this as best as really possible, I guess, we need to do an update down below, and yeah, that looks good. Okay, yeah, let's do an update down below in the flat top hex section. We're going to go ahead and remove that tile width, and we're going to go ahead and get the tile height instead. If you notice that I said tile height, but I grabbed the tile width. Alright, you can probably skip ahead if you want, but I have to go futz with my models again. I do want to make the center point a little bit better. You know, it just, for some reason, I have a heck of a time with Pro Builder. So I'm going to go ahead and update these again. I'm also going to create a small widget for the center of the hexes or squares, so that later on that small node can grow out of the hex itself, similar to the intro screen shows. Alright, so now that I redid those, I can actually try the pointy hex and the flat hex to make sure that they both work. So here is the flat hex. Make sure you check mark so is pointy is not checked. And there we go. That looks like a grid to me. Great. So here's I'm going to create that small widget. It's just a very small little box that's going to go into the center of the square and the center of the hexes. So later on it will grow out and the links will grow out of that center piece. I'll also create a matte black material that we can apply to the square, and we will also apply that same black material to the linking components later on. Once this looks centered in the hex, we'll go ahead and make it a child object of the hex and then update the prefab. We are going to do exactly the same thing for both the flat top, pointy, and the cube or square. So bear with me while I go ahead and add that same square object to each of the model prefabs, and then we're going to go ahead and update the prefabs. Alright, now that everything is updated, we'll go ahead and give it a go. We'll go ahead and drag and drop our square into our game manager. Make sure that the is hex is unchecked, and see how it looks. Alright, so we need to try that again. Make sure that box is unchecked, and notice that there are bounding boxes around the game manager, and everything looks good. Hope to see you in part 4, where we will work on directional logic for both the cubes and the hexes. Thank you.